On this episode, we showcase the journey of FlexGen, a company delivering cutting-edge integrated energy storage systems with a functionality and software-first approach. Hear about their journey with the AWS Prototyping team in bringing generative AI to streamline operations of complex energy systems at scale and building the reusable patterns for continuous innovation. Well, I am excited to welcome the Chief Technology Officer from FlexGen, Hugh Scott. Hugh, thanks so much for being here with us today.
My pleasure.
And from AWS, we have our Senior Prototyping Architect and Security Specialist, Allison Pryor. Allison, always great to catch up with you.
Equally, thank you.
So, Hugh, for our international listeners, can you share a little bit about what FlexGen does?
FlexGen is a software and services company focused on the battery energy storage systems, which is, you can think of battery energy storage systems as large industrial batteries and power inverters that sit normally in front of the meter and feed power directly onto the electric grid. In other words, they're power plants, but within the power plants, they're actually batteries.
Very interesting. So tell us a little bit about the technology estate that you have there to run these massive power plants, essentially, right?
Yeah, so our product offering is we call Hybrid OS, and it's our energy management system. And it is the software that you use to coordinate the battery and the inverter so that when you press the button to send power to the grid or to take power from the grid, so charge or discharge, that it actually happens the way that you want it to happen. It's easy to fall into the trap when you think about batteries. Well, there's no real moving parts. So it can't be as complicated as a gas turbine power plant. But actually, if you think about what constitutes a battery, it's hundreds and hundreds of individual cells, each of which are, there's lots and lots of chemical reactions taking place as the individual ions are either charging or discharging. So what we're doing is we're coordinating everything within the battery and making sure that that works nicely with the inverter and the energy that's stored in the battery, which is stored as DC current, gets converted to AC current and matches the frequency of the grid as the energy is discharged.
So your customers could be traditional or sustainable energy companies, or?
Yeah, we have a mix of customers. We have many customers that run these like they would run power plants. So most obvious use case is they'll charge the battery when energy is cheap. And so if you're on a grid where there's an abundance of the wind power generation, the wind might blow at night or the sun might shine during the day. And so our customers would charge their battery then when the energy is more abundant, and would then have the opportunity to discharge the energy when it's slightly more scarce, which is normally, around the beginning of the morning as people are starting their morning commute or when they're getting back from work. You can think about batteries as really time-shifting energy so that the time that the energy is being produced can now match the time that the energy is being consumed.
Right. So fascinating. So tell us a little bit about how you came to work with Allison and the AWS prototyping team.
Yeah, well, we started working with AWS, almost a year ago. We were starting to think we had some real opportunities to improve our cycle time. One of the things we're always looking to do is to accelerate our pace, reduce the amount of time to the first dollar that our customers can make. And so what that really means is when we are commissioning a battery site or commissioning our software, the cycle time needs to be as short as possible.
Sure.
It's very easy for commissioning to stretch out into months and sometimes even years. And so we've been very focused on reducing that cycle time as much as we can. One way we've done that is by focusing on how can we accelerate the speed at which we integrate our software with the equipment manufacturer's hardware. And in doing that, we work on something called a Modbus mapping, which Modbus just being the industrial protocol that we use for our software to communicate with the battery. And it's a fairly manual and somewhat time-consuming process. What we did was we were working with AWS initially on leveraging generative AI and large language models to accelerate the speed at which we were doing that. And it took something that was, taking days or weeks and turned it into something that we were able to do in minutes. And kind of going on that voyage, we realized that there was an opportunity to use that technology or something similar to solve other business problems that we might have.
Absolutely. And Allison, that's where you came into the picture. Is that right? Mm-hmm.
Correct. So they had identified an additional use case for helping their agents that are either on site at a client's infrastructure or remote at the FlexGen rock site monitoring space. And they wanted to help those agents be able to get better data and quicker data in order to help do troubleshooting and help onboard new agents faster. There is a lot of data, and when you are dealing with energy, there is a lot of safety concerns that come with that, both from a personal as well as a infrastructure standpoint. So making sure you have the right information for the scenario is critical, as well as making sure it's site-specific information.
And so these rock agents, is it called rock agents? Is that right, Hugh? So these rock agents are out there working with your customers, helping them both set up and also streamline their operations, do any kind of troubleshooting and maintenance?
Yeah. I mean, typically the rock operators that sit in our, called rock operators because they're sitting in our remote operations center.
Got it. Okay.
Here in Durham, North Carolina.
Okay.
I mean, as Allison said, there's a lot of data coming in. I kind of use the example that you could have, two sites that are exactly the same, doing exactly the same thing. But if they're owned by, a different operator or managed by different operators, what you do with the data might be completely different depending on how that particular asset operator wants you to react to that information. So the focus is all really about making sure, obviously, the safety of the site, as Allison said, is paramount. But secondary to that is making sure that the sites are operating as efficiently as possible. And, one of the things we're very proud of at FlexGen is our system availability. We've had the system availability of sites that operate using FlexGen's hybrid OS benchmarked, and we offer the highest availability in the marketplace. And so, and a lot of that's down to obviously the efficacy of our software, but a lot of that's down to the hard work that's done with our rock agents. And so the problem that Alice and I discussed was, look, the rock agents do a great job, but the amount of time it takes to train a new rock agent is, 4 to 6 months. So the bringing somebody on is it's really an effort. And given the growth that we are seeing as a company and the growth that this particular sector is seeing, we're constantly adding people. And so you can imagine the training cycle time that's required to kind of grow your staff can be quite considerable. And so the thought was, hey, look, this feels like maybe a use case that was tailor-made for generative AI.
Absolutely. Sounds like it. So tell us a little bit about how you set that up. So you've got both data coming in from the systems themselves, and also you might be talking to humans, and then you have that rock agent in the loop. Allison, talk us through a little bit of the technology, the architectural patterns that you use to um, work with Hugh and the team to build a solution.
Of course. So the initial approach was to focus on, one customer with potentially multiple sites so that we could see the differentiation in documentation while also having a singular customer to deal with and keep it scoped to something that works within the prototyping timeframe
Sure.
of that 4 to 6 week development cycle. And so what we ended up doing was leveraging S3 for storing a lot of that static data. They provided us tickets, some time series data from some of the instrumentation. And so what we did is we were able to leverage Amazon Bedrock with the embeddings from some of our partner models and then Bedrock knowledge bases to create a vector database in order to store those embeddings so that the models could actually do retrieval augmented generation or RAG type queries in order to understand, okay, here's additional context within the operational procedures, policies, past tickets or issues, as well as potentially looking at current state of data as it was streaming in to that time series. Now we had kind of a snapshot in time for that, but in talking with FlexGen on how they could extend this towards production and potentially integrating time series databases into the solution, it is feasible that a agent and a tool could be built to help them actually get current state as well as operational procedures. So what we built is a demo UI for them to both ingest new data as well as create tickets because they're a ticket-based process on evaluating potential issues at sites. We effectively helped build that part into that UI. And ultimately, it was a interaction with a model in a conversational state. So they
Mhm.
could either take an existing ticket, open up a chat window and start conversing with the model, or they could start a new chat with the model and ask more generic questions with
Mm.
that. And then once the conversation was finished, if the rock agent felt that that was valuable information that could be beneficial for future use cases, or they were working a case that they wanted to save, they could actually save the history of the conversation with the model, plus any of the documentation and other embeddings that the model had access to as a new piece of historical data that itself was turned into an embedding and stored in a
Mm.
vector database. So the, we called it this system of kind of learning or relearning,
Right.
just from the perspective of it could actually know what has happened in the past without having to maintain that in memory like a more traditional conversational chat.
Interesting. And so, Hugh, the folks who are going to be interacting with this chatbot are those rock agents, and now they have at their fingertips not only all of the standard operating procedures, the data that are coming back from that system, as well as that historical information, plus all of their human intelligence and experience to bring into a solution for your customers. Is that sort of the
That's absolutely right. Yeah,
Mhm.
that's absolutely right. I mean, I think that, so first of all, we nicknamed this the Rock Bot, and nobody's come up with a better name. So that's the name that we're going with. Um, but yeah, you're absolutely right. I mean, we wanted to have a human in the loop. Initially when we were talking about this, I was a little bit, hey, we can get rid of people altogether and we'll be so efficient. And very quickly I realized that was a bad idea. But I mean, this, like I said, this use case is perfect because, not only does it accelerate the speed at which a rock agent can become useful, but it allows us to improve the knowledge base,
Right.
given what individual rock agents actually do. So,
Mm-hmm.
there's the, I think everybody talks about, there's the if you use driving as an analogy, right? There's the rules of the road,
Right.
and then there's the way people actually drive.
Mm-hmm.
And so, what this does is it captures not just the rules of the road in the documentation and the vector database, kind of that Allison was talking about, but it takes what people are actually doing and vectorizes that and captures how people are actually driving, to kind of use that analogy, and make sure that it kind of constantly learns and improves.
Mm-hmm. And so this you're using for like sort of operational efficiencies. What are the kind of questions that would come into the rock bot plus the rock agent?
Yeah. So I mean, like a typical, I mean, there's so many different things. There's literally thousands of pieces
Right.
of data. I think we categorized it down into 12 different kind of use cases. But for example, what do you do if you get a high temperature warning on a
Right.
particular battery rack? What is the procedure to do that? And typically, you would disconnect that particular rack from the rest of the battery, and then you would run some diagnostics, and you might even actually choose to mobilize a crew to go and physically visit the site. But different sites, different batteries, different configurations have different thresholds.
Right.
And so it's not as simple of we'll just wait for that number to get to, 94 degrees and then we send somebody out, right? It's very, very kind of, it's not subjective, but it's very dependent on a multiple factors.
A lot of complexity in the model, a lot of complexity in that decision making. And so as much as you can help give more and more context to these rock agents, the easier it is for them to do their jobs, I'm sure.
Yeah. And I mean, ultimately, the goal is not just to, not just kind of detect things, but to get ahead of detecting things so that, we're really focusing on this idea of availability. And if through using our software and our rock, we can get ahead of issues before they actually become issues, that's where the real value in this is.
Right. That preventative sort of maintenance, proactive. Yep.
100%. Yeah.
Yep. That's right. I want to go back to something you said earlier, Allison, around like feeding that knowledge back in and building up that knowledge system, sort of that iterative approach to bringing together the system and making it more effective and reliable. Can you talk through some of the technical challenges that you had in that?
So I think one of the initial challenges that we encountered was really this understanding the depth and breadth of the documentation that we were being given, and also the different ways in which that documentation can be chunked, which is a technical term for kind of splitting documents up in order to be converted into embeddings. And the reality is that we found out through some testing that wholly monolithic documents can bring information that is not relevant to the topic at hand. It's not a hallucination in the essence that the model was making something up, but it was providing information that was not valid for the situation that was being discussed between the rock agent and the model itself, which for an experienced rock agent could potentially lead them down a path that would be incorrect procedure for taking advantage of that. So it was looking at how do we handle the ingestion of the documentation and making more specific procedures around specific topics. So, for example, AC-based procedures versus DC-based procedures, so that you're splitting that context up so that you don't inadvertently have maybe two sections of two different procedures that got chunked and were embedded and now are kind of similar from a database search, but are actually referencing two different things. So that was one area. The other part was obviously prompt engineering. We didn't really get into kind of an abstraction component of putting a lot of logic in front of and behind the model to validate what was going in versus what was coming out, which is typically something you'd want to do going to production so that you can validate those answers that the model's giving you and potentially put some of that logic in place, where if you, as a battery management system, know that, doing procedures against AC systems following DC-based practices is probably not a good idea, you would be able to have like a filter on that to say, that's probably not right. Let's think about this some more.
You're putting the wrong input in there. Right. Yeah.
Well, the model was just giving the information that it found represented the next logical step in the conversation, because it wasn't that it gave us the wrong information off the initial question. What it was a series of questions and conversations that became more and more specific around a certain voltage. What happens when an AC breaker hits, 3.6 volts, for example? And then once it locks open, how do you get it to close? And so as we did this iterative effort of what are the steps to use, we found that it was giving some of the instructions. And then when we reiterated and further clarified some concepts, it gave us more of that instructional procedure that the ROC agent should follow. And then we're like, well, what else should we be thinking about? And that's when it was like, oh, well, here's some stuff. And it brought in some stuff about DC procedures, which, again, not relevant to the current situation, but not false or incorrect or invalid data either, assuming we were in the correct conversation, which in this case it wasn't.
So, Hugh, that learning and making sure that also the ROC agents themselves are aware of how to interact with the system. Not only can you, obviously, you want to design it in such a way that it's accurate and only brings the context that is relevant to the particular question, but also having the ROC agents themselves understand the nature of the questions that they're asking. Is that?
Absolutely. Yeah. I mean, Allison's example is a great one. If you're asking a question about, a DC system and you get AC answers or vice versa, that's a problem, right? And, the agents are educated enough to understand the difference. But the key thing is the human was still in the loop. Right. And so, when we approached this, we were very clear that the operators were still the decision makers here. We weren't abdicating decision making to the ROC bot. It was just finding relevant information. And one of the things I thought actually that team did that I thought was incredibly helpful was when the bot returned an answer, it actually returned a confidence level as well. And so what that did actually, I think, from a technology standpoint, obviously that's measuring, well, how accurate, does this match in terms of, correlation coefficients, etc. But from a psychological standpoint, it's reinforcing with the ROC agents. This isn't a guess, right? It's a very educated guess, but the system is essentially guessing based on what it's seen before. And I think just having that little bit of text at the end of every single recommendation, just I think had that psychological reinforcement that, look, you're dealing with artificial intelligence, it might make mistakes.
Right, right. It's so interesting to have that be part of your process and to train your people in that way. Of they're still, I love the way you characterize that as that autonomy still exists for those individuals. Tell us a little bit about where we are now. So Allison and the team were out there helping you. You got this Rockbot up. What are the next steps to putting this into practice?
Yeah, so we're taking that to the next stage. We're looking to implement that, initially roll it out to the Rock. As Allison said, this was, we supplied a snapshot of data, but
Sure.
there's thousands of data points coming in real time. And so what we want to be able to do is consume that data as it's coming in and allow, continuously updated recommendations based on what's actually happening.
Right.
The documentation's changing. The procedures might be changing. And obviously, voltage and temperature are definitely changing, right? And so
Right.
we want to update the implementation to reflect that. But I'd say as well, it's piqued interest within the company to having this solution used in other areas of the business, right? So, there was discussion around, hey, we have to fill out, a lot of questionnaires that all look very similar, but it's maybe a 30-page questionnaire. Could we have the AI model at least take a first pass at completing these questionnaires before we submit them? Or, creating sales proposals, right? Like, it's a very manual process sometimes, gathering data. It's all around, but, is there something that we could use where, maybe we would have the AI model help our business development team in piecing at least the initial version of the sales proposal together?
I really love that, Hugh. Part of what we're trying to do with prototyping is we often say teach people to fish instead of giving them the fish, right? The idea of taking these patterns, some of the infrastructure, et cetera, that have been put in place, and then to reuse those concepts and that approach in different areas of the business is absolutely what we have in mind there. So that's wonderful to hear that sparking that inspiration and folks thinking bigger about how they can use technology to increase both the velocity of your operations, but also the resiliency and security and quality of the work that you're doing. So that's fantastic to hear. I'm wondering if, as you reflect back on the engagement, I'll give you, Allison, you, and then go to you, Hugh, for final words of what you might share with our listeners about what you learned or what they might consider when they're looking at infusing new technology into something that's been heretofore very people or person oriented process.
I'd probably point out just the fact that, as with anything else, there's no magic here, but it can be very magical. But it takes a lot of time, effort, and hard work, and potentially some failure to get you to that magical state. And as long as you're failing in the right, you're going to land somewhere where you're going to be able to see the potential possibilities and the excitement that comes from some of these new technologies. We're working with other customers and engagements right now where we're continuing on this path of what I would call virtual employee assistance tools, where we're taking that undifferentiated heavy lifting of a task and looking at how do we leverage these AI tools to help, not necessarily replace people, but to make those more mundane manual tasks get done in a much quicker, more efficient, and ideally more accurate way as we move forward.
Mm. Yeah, fantastic. Yep. And final words for you, Hugh. What would you share with our listeners?
Yeah, yeah. I'd say a couple of things. I think just building a little bit on what Allison just said. Don't be afraid to make mistakes. I've been in technology long enough now to realize the dangers of demoing something live. And Allison will remember, we were on a video conference, and I think there was maybe 30 people on the call. And the VP of our remote operations center said, "Hey, look, let's just try this right now. We're going to get the senior rock operator in, and he's just going to type a question, and let's just see if this thing actually works." And I think we all held our breath for a second.
Mm-hmm.
And he came in, very senior guy, has been doing this for years. I don't even remember the question he asked, but he typed a question, and he was like, "Oh, well, that's wrong." And I think we were all thinking, "Oh shoot, like this doesn't work. Like, what are we going to do?" And then we realized, hey, you just need to be a little bit more precise with your question. Question was a little vague, right? And I think it was actually around the AC/DC thing. He'd asked something, and it wasn't clear, which side of the system he was querying. And so when he clarified that, he immediately got the right answer. And you could see that he was impressed. And so, and we were impressed and maybe a little bit relieved that it had gone quite well.
Yeah.
The second thing I'd say is focus on the knowledge exchange at the end of one of these interactions. I was blown away. Like, it was great, right? Like the proof of concept worked. And I was kind of like, yeah, I don't need any knowledge handover, right? Like, what do I need to learn, right? Like, this isn't rocket science. And we spent a day here in Durham with Allison and the team. And we went through, almost line by line with, the implementation to understand it. But what was eye-opening wasn't the specifics necessarily of how the solution was implemented, but it was the pattern, the architectural pattern that was used, and how the team had taken advantage of some of the AWS services, and that there was a light bulb moment, I think, for all of the FlexGen employees in the room. We were like, okay, now I think we really understand how to do this, and it's not that hard, but I think it would have taken us a while to figure that out on our own. And so we feel much more confident, much more capable of taking this and extending it elsewhere within the company.
Well, that's fantastic to hear. Well, Hugh, Allison, thank you so much for being here today and sharing your journey with us.
Thank you.
Fantastic. Thank you.